Okay, we're ready to do Notes 11D for the Math 4 course. Wow, y'all think about it. This is the last set of notes that I will be giving you for the course. Everything after this is going to be review and test. All right, so let's move on with complex numbers. Today we're going to talk about multiplying them. And while it sounds easy enough, there are a couple of issues that we need to watch out for. Now, I've probably talked about this before, but the idea that when you are multiplying two binomials like that, you can either do FOIL or you can do the box method. I am okay with either one. You're going to see me do the box method here, and I have my reasons for that, but I am not going to try and change your mind if you want to FOIL this instead. You are perfectly fine to do that. Now, by the time I finish multiplying 6i times 4, that's 20. Wait a minute, no. Plus 6i, yeah, okay. That's 24i. And 6i times 7i is 42i squared. Now, that's one place people have a tendency to screw this up, is they forget I times I is I squared. Now, by the time we lay all of this out, we are going to have some like terms that need to go together. For instance, 14 and 24 become 38i. But now this guy down here, I squared is the same thing as -1, which means now we're talking about minus 42. 8 minus 42 is -34 plus 38i. Now, I squared is never a final answer. Because anytime that you have I squared in your final answer, it can always be replaced by a -1, and next thing you know, you have a real number on your hands and not an imaginary one. So, that's for that one. Now, let's try another one just like it, but this time it's got a negative involved. We're going to create our box again. We're going to say 4 plus 7i and 2 minus 3i. And by the time that I start multiplying, 2 times 4, 2 times 7i, -3i times 4, -3i times 7i. That's going to give us -21i squared. So we're going to have 8 plus 14 minus 12, that's plus 2i, minus 21i squared. Now that's going to be the same thing as saying -21 times -1 is positive 21, which equals 29 plus 2i. Okay. Now, we need to step into a topic called conjugates. You actually already are familiar with conjugates, whether you realize it or not, is when we were doing this stuff right here. A plus B times A minus B equals A squared minus B squared. Those were conjugates. Whenever you have the plus and the minus version of the same thing, the mathematical term is those are conjugates. Now, watch what happens when we box this guy right here, A plus BI, A minus BI. Okay, so by the time we start multiplying A times A and A times BI and negative BI times A and negative BI times BI, we get negative B squared I squared. And so when we go here to spell all of this out, aren't we going to lose these two guys? Positive ABI and negative ABI, they're going to cancel each other out. And all we're really left with here is that, which If I've got a negative b squared times a negative 1, that's going to make it a positive b squared. Well, looky there. There was an unexpected surprise. Instead of a squared minus b squared, this is going to be a squared plus b squared. But considering that I squared is in the mix, this should not be terribly surprising. So watch what happens when we do it down here. To 3 plus 2i, 3 minus 2i. Watch what happens there. So if we're going to use this as a and this as b, then our final answer is going to be a squared plus b squared. That's going to be 3 squared plus 2 squared equals 9 plus 4 equals 13. Wow. We have no more imaginary numbers whatsoever. It's all real. Now, conjugates do not always lead to a real number, but it did that in this case. And we're going to see something like this down here. They really don't like it when you leave I on the bottom. I on the top is okay, but not on the bottom. So how are we going to get rid of it? We're going to get rid of it by multiplying it by its conjugate. Now what's going to happen on the bottom is we're going to get negative 4i squared. But on the top, 6 times that is going to give me negative 12i. 3i times negative 2i is going to give me negative 6i squared. Now, negative 6 times I squared is negative 6 times negative 1, which means we're really dealing with plus 6. Meanwhile, down here, the same thing is happening. Negative 4 times negative 1 becomes positive 4. Now we just need to put things in the proper order. Now, it's not unreasonable to look at that and say, you know, we could reduce this. Everybody is a multiple of 2. Now, that would be a perfectly acceptable answer. It is possible on some of the pre-printed stuff that comes from other sources, you know, because sometimes I'll do that on a test. I'll you know, copy something from another source. And sometimes you would see it left that way, where they would separate the fraction 3 over 2 and 6 over 2. But again, all of these are perfectly acceptable answers on the end. All right. Now, this one is the last one. When we multiply by the conjugate, that is going to be 2 plus I. And of course, we got to do the same thing to the top. Now, what we've got going here is a set of calculations on top and a set on the bottom, and we're going to have to treat them separately. So let's start with the top. Well, the top, we're going to make a box. And we're going to say 3 plus 4i, 2 plus I. And we're going to multiply 2 times 3, 2 times 4i, I times 3, I times 4i, which means that we're going to have 6 plus 11i plus 4i squared. And that 4i squared is about to become minus 4. 6 minus 4 becomes 2 plus 11i. So we're going to start with 2 plus 11i on top. And then we're going to figure out what's going on the bottom. Bottom is going to be that if this is A, B is going to be an understood 1 in front of the I. That's 2 minus 1i, 2 plus 1i, right? So A is 2, B is 1. So if we're going to say A squared plus B squared, that's going to be 2 squared plus 1 squared, which is 4 plus 1, which is 5. Now, we can also write them in this fashion. Either one of those would be fine. And we are done with the notes for the course.